A chemist needs to mix an 18% acid solution with a 45% acid solution in order to obtain 24 liters of a 36% acid solution. How many liters of each of the acid solutions must be used? In this case, we're mixing two different chemicals, one that has 18% acid and one that has 45% acid, to try and produce a third chemical that has 36% acid. When they ask us how many liters of each of the acid solutions must be used, they're asking how many liters of the 18% solution and the 45% solution, because those are the ones that we're actually using to do the mixture. So those are going to be represented by X and Y. The first one is the 18% solution. So let's let the amount of 18% acid solution be X, and then let's let the amount of 45% acid solution be Y. There won't be a let statement for the amount of 36% acid solution for two reasons. First, it's not one of the things that they're asking us to look for. They're looking for how much of the solutions that we're using to mix. That's the end result. And also they tell us we need 24 liters of the 36% acid solution. So these problems are always going to have three different solutions. Two of them are the starting solutions that we're mixing together, and the third is the resulting solution. And our let statements will always represent the starting solutions. Once we have our let statements, we can use a table to organize our information. And with these mixture problems, we actually use a larger table. There's going to be one more row. And you'll see why in just a second. Let's start by labeling the tops of the columns. The relationship in these mixture problems is solution times concentration equals ingredient. So that's how we'll label the top of the columns. And then we have to label the rows. And it's important to do this in the right order. The first two rows are going to represent the two solutions that are our starting solutions. In this problem, they say the chemist needs to mix an 18% acid solution with a 45% acid solution. So the first one is going to be the 18% solution. The second one will be the 45% solution. And when they're mixed together, we need to obtain a 36% solution. And that is how we're going to label that third row. There's an extra row in these problems because when we take the two starting solutions and mix them together, we end up with a third one. Now let's fill in the table with the information that we have. Let's start in the upper left-hand corner. That's the amount of the 18% solution. And we didn't know how much that was, so we assigned it a variable. We said, let the amount of 18% acid solution be X. So that's going to be X. For the 45% solution, the amount of the solution is going to be Y. That was also from our let statements. And then at the bottom, they ask us how much of the 36% solution should there be. But if you look in the original problem, they tell us the chemist wants to obtain 24 liters of the 36% acid solution. So in this case, that's going to be 24. That one's not a variable. They tell us how much they want. Now the concentrations we can fill in. Those are just the percentages. And as a decimal, 18% is 0.18. 45% is 0.45, and 36% is 0.36. To figure out what goes in the ingredient column, we multiply across because solution times concentration equals ingredient. So in the first row, x times 0.18 is 0.18x. Similarly, in the second row, we end up with 0.45y. And in the third row, we actually multiply the numbers. 24 times 0.36 is 8.64. Now, since we have two variables, we need to write a system of two equations to model the situation. And just like the last problems we looked at, the interest problems, with these mixture problems, the equations are going to come from the first column and the third column. Let's look at the first column, the solution column. We know that the first two solutions, the 18% solution and the 45% solution, are getting mixed to form the 36% solution. If we know that there are going to be 24 liters of the 36% solution, that's the total of all the solutions we mix together, and that means that x plus y has to equal 24. We don't know what x and y are. We don't know how much of the 18% solution and how much of the 45% solution we used. It could be 12 liters and 12 liters. It could be 20 liters and 4 liters. It could be 23 liters and 1 liter. But however the mixture is, because we have to end up with 24, we know that whatever x and y are, x plus y has to equal 24. Now, if we look in the ingredient column, these tell us how much of the acid is in each of the solutions. Because it's not all acid, it's only a certain percent. So if we look at the first one, there's 0.18x liters of acid. And in the second one, there's 0.45y liters of acid. We know that we need 8.64 liters of acid because that's 36% of the 24 liters in total. So because we need 8.64 liters of acid in total, if we add the amount of acid from each of the solutions, we should have a sum of 8.64. That means 0.18x plus 0.45y equals 8.64. And now we have our system of equations, which we can solve using substitution. I'm going to isolate the x in the first equation. To get the x alone, we have to subtract y from both sides, giving us x equals 24 minus y. And now we can set up our substitution. Because x is equal to 24 minus y, wherever we see an x in the other equation, we can replace it with 24 minus y. So in the second equation, when we make the substitution, it'll become 0.18 times x, which we know is 24 minus y, plus 0.45y equals 8.64. Now we have to distribute the 0.18 on the left. When we do that, 0.18 times 24 is 4.32. So we have 4.32 minus 0.18y plus 0.45y equals 8.64. We can combine like terms now. If we take negative 0.18y plus 0.45y, we end up with 0.27y. So we have 0.27y plus the 4.32 that we had before, and that equals 8.64. We can subtract 4.32 from both sides at this point. When we do that, that gives us 0.27y equals 8.64 minus 4.32 is just 4.32. And when we divide both sides by 0.27, that gives us 16. Going back to our let statements, we know that y is 16, and we know that that's the amount of the 45% acid solution. So we've got 16. And since the solutions were measured in liters in this problem, that's going to be 16 liters. There's two ways to figure out the value of x. X represents the amount of the 18% acid solution, the other one. But if we know we need 24 liters in total, and we used 16 liters of the 45% acid solution, 24 minus 16 leaves us only 8 liters for the 18% acid solution. But we can also figure this out via substitution. We know that x is 24 minus y, but we figured out that y was 16, and 24 minus 16 ends up being 8, so we know that x is 8, which means there are 8 liters of the 18% acid solution used. So in the end, to state our conclusion, it asks how many liters of each of the acid solutions must be used. We can say they must use 8 liters of the 18% acid solution and 16 liters of the 45% acid solution. And that is our final answer.